Welcome to this explainer. You know, every single time you learn something new, an actual physical transformation takes place right inside your head. Today, we're going to dive into how your brain structurally changes when you pick up a new skill or memorize a new fact, all based on the brilliant research of Dr. Lara Boyd. So if you think you're just passively absorbing information right now, well, get ready to see how you are literally rewiring your mind. Here's exactly what we're going to cover today. 1. Common myths about the brain. 2. The 3 mechanisms of neuroplasticity. 3. The puzzle of stroke recovery. 4. There is no magic recipe. And 5. How to create the brain you want. Let's get into it. Section 1. Common myths about the brain. For the longest time, it was basically accepted as absolute medical truth that adult brains just couldn't change after childhood. We all thought your brain's structure was pretty much locked in for life. We also kind of thought the brain essentially shut down and went quiet when you were resting. But thanks to modern tech like MRI scans, we now know these ideas are completely, totally false. Your brain is highly active, it's constantly evolving, and it's heavily engaged even when you think you aren't doing anything at all. And that brings us to the core concept of our whole explainer today, neuroplasticity. Basically, this is the brain's incredible ability to reorganize and change its actual physical structure every time you learn a new fact or skill. Now, this is a massive reversal from just 25 years ago, when scientists thought adult brains only changed in negative ways, like through aging or brain damage. The amazing truth? Change is happening up there all the time. Moving on to Section 2, the 3 mechanisms of neuroplasticity. So, your brain doesn't just change in one simple way. It actually transforms in 3 very specific, distinct ways: chemical changes, structural changes, and functional changes. They all work together to support your learning, but the catch is they operate on very different timelines. The absolutely crucial part here is understanding the difference between the first 2. First, you have chemical changes. This is where your brain rapidly increases chemical signals between neurons to support short-term memory and short-term motor skills. But then, you have structural changes. These are literal physical alterations in the connections between your brain cells that actually support long-term memory. If you've ever absolutely crushed a piano piece in one afternoon, only to completely forget how to play it the very next day, well, that's exactly why. The chemical changes happen super fast, but you just didn't put in the sustained practice required to force those permanent structural changes. To make this super concrete, let's look at some fascinating real-world examples of structural change. People who read Braille literally build larger sensory regions in their brains compared to people who don't. And London taxi drivers, who have to memorize this massive, incredibly complex map of London streets, they have demonstrably enlarged brain regions dedicated to spatial memory. Their specific, repeated, everyday behaviors physically built larger, specialized regions inside their heads. How cool is that? And finally, we've got functional change. As you use specific brain regions more frequently, they become highly excitable and just way easier to activate. As entire networks become more efficient, your brain literally shifts how and when these regions activate together so they can seamlessly support your new skills. So chemical, structural, and functional changes are all happening together, like a giant puzzle to make learning possible. Section 3, the puzzle of stroke recovery. Now, this raises a huge question. If neuroplasticity is really this powerful, and our brains are so wonderfully adaptable, why don't people fully recover from brain damage? Dr. Boyd's research tackles this exact paradox, questioning the limits and the facilitators of neuroplasticity, especially when it comes to stroke patients. We are facing a really complex societal problem here. Stroke has thankfully dropped to the 4th leading cause of death in places like the US, which means we've gotten a lot better at keeping people alive. But the actual incidence rate hasn't dropped at all. This makes it a leading cause of long-term adult disability worldwide. We've largely failed to develop highly effective rehabilitation that fully cures the long-term disability that follows a stroke. The harsh reality of why recovery is just so overwhelmingly difficult comes down to this. The primary driver of change in your brain is your behavior. There is absolutely no neuroplasticity pill you can swallow. Recovering a lost motor skill requires a massive, exhausting dose of behavioral practice to literally force the brain to structurally rewire itself. And honestly, delivering that amount of practice effectively is immensely difficult and really costly. Which leads us perfectly into Section 4. There is no magic recipe. 10,000. You have probably heard of the famous 10,000-hour rule, right? The one that suggests mastering any new skill requires 10,000 hours of practice. Well, Dr. Boyd's research proves this incredibly popular concept is actually fundamentally flawed. It is just not that straightforward. The truth is, neuroplasticity varies radically from person to person. Because every single brain is structurally and functionally unique, statistical variability means there's absolutely no universal recipe for learning. For some people, mastering a skill is going to take way more than 10,000 hours of practice. For others, it'll take significantly less. One size simply does not fit all. Think about how this connects to the broader scientific world. Just as modern oncology uses a patient's specific genetics to personalize their cancer treatments, Dr. Boyd argues we have to start using structural and functional brain biomarkers to personalize stroke recovery. And we really need to take this concept even further into our daily lives. Learning requires personalized education. We have to start matching specific teaching interventions with individual learners. All right, our final section, section 5, create the brain you want. Have you ever wondered why our children sometimes just fail in school? Understanding individual brain variants perfectly explains why some kids struggle immensely in traditional one-size-fits-all classrooms, while others can effortlessly pick up new languages or excel at sports with seemingly no effort at all. We all have beautifully unique brains, which means we all require entirely different approaches to effectively trigger neuroplasticity. Now, here's where it gets really interesting and, honestly, kind of intimidating. Neuroplasticity is a double-edged sword. On one hand, you have positive plasticity, learning new skills, improving your memory, recovering from an injury. Fantastic stuff. But on the other hand, you have negative plasticity. Your brain is shaped just as easily by your bad habits. Forgetting skills, building drug addictions, and even getting stuck in chronic pain loops are all real examples of your brain efficiently rewiring itself based on negative behaviors. So let's distill all of this down into the core takeaways. First, your behavior is your primary driver of change. Second, your brain is shaped by what you do and by what you don't do. Every single action and inaction plays a part. But this third point is perhaps the most vital. Increased struggle and difficulty during practice actually leads to greater brain change. To truly learn, you have to embrace the struggle, knowing for sure that the difficulty itself is the exact mechanism causing your brain to structurally adapt. So, go out and build the brain you want. Because believe it or not, your brain literally will not be the exact same at the end of this explainer as it was at the very beginning. Simply by sitting here and absorbing this information, you've triggered chemical and maybe even the beginnings of structural changes in your head. Knowing that every single habit, action, inaction, and struggle physically alters the permanent structure of your mind, what kind of brain are you going to build tomorrow?